So we're going to begin this experiment by taking some basic measurements. So we're going to start with the measurement of the cart. So this is the cart, and so we're going to put it on the scale here. And so you can see the measurement in grams. So that's the mass that you're going to be using for this experiment. And the next thing you're going to do is measure what's called the effective length. And so we're going to use this instrument called the photogate. And so what the photogate does is it measures the amount of time that, if you notice here, there's basically an infrared beam and a detector. And what happens is when you push the cart through the gate, it sends us, or the gate no longer has a signal and it's being blocked. And you can see that for as long as it's blocked, you get a time reading, and this time reading is in milliseconds. So we'll take it out and reset it to 0. So what we want to do is measure the effective length. Basically, the position of the cart, when the difference between the position of the cart when the gate starts to be blocked and when it stops being blocked. So you're basically going to start to move it through, and you'll know when you get something other than 0 that you've got it, that you've got it blocked. So you're basically trying to move it a millimeter at a time. All right, so at about 975 millimeters, you have that. And so now you're going to keep going through, and you're going to move it slowly. You want to keep moving it forward until it stops. Okay, and you're going to want to mark that position here. And so that's 1,073. So it's 1,073 minus 975, and that's in millimeters. And so that comes out to about 98 millimeters, or 9.8 centimeters. And that's what you're going to use as the effective flag length. And so what's going to happen when I get this set up, we're going to turn the air on, and it works like air hockey. That it basically eliminates the friction. And so the cart is going to start here, and it's going to move, and it's going to be pulled down by masses on this side. And so when the masses hit the ground, it's no longer going to be accelerating, so it's going to coast through the detector at a constant speed. And so you figure out that speed by dividing the effective length, which again we just found out to be 9.8 centimeters, divided by the time it takes to cross this. And so the time is given in milliseconds. So when I was moving it before, I had it blocked for about 22 seconds, or 21.9 seconds. So this reading is in milliseconds. So what I'm going to do is turn off this recording for now, but I will set up another recording once I've got the experiment set up, and we will take it from there.